Hey everyone, welcome back. So in the last video, what we talked about was what is this thing that you might have heard about called a pointer? What is this data type that you might have heard of called a pointer? And so what we did is we created just a regular integer and gave it a value, something y'all should hopefully be used to by now. And then we printed out that value, but I also printed out the address that integer example was stored at. And then what we did was we created an integer pointer. And so this is the syntax for creating a pointer. We say the data type of the thing that we want to create. We use the star to say that it's a pointer, and then we give it a name. And so we created an integer pointer called example pointer. And what I set that equal to, the value that I gave that variable, was the address of our integer that we created up here. Okay, and that again is really all that integers are, is just addresses. Okay, and then we printed out that example variable down here. So today what I want to talk about, before we actually jump into really using these pointers, is I kind of want to talk about some behind the scenes, like under the hood stuff, so that way you all know what the heck is going on here, right? So what is a pointer? So what I'm going to do is, it's an address, right? Hopefully that we've learned. What I'm going to do is I'm going to jump over here to a whiteboard because I want to talk about some of the different ways in which we might use these pointers, all right? So what we just did, let's take a look at what we just did here. If I can find my goofy pen. Okay, right here. So what we just did was we just created an integer and then used a pointer to store its address, right? So if I've got memory, let's say that I'm going to kind of represent memory like this, okay? I don't know what's going on there. Oh, all sorts of fun things. All right, let's try that again. Let's say I've got memory, and I'm going to represent memory like this, okay? And each of these spots, let's say that these are all spots for integers. This isn't exactly how memory works, but I don't want to overcomplicate things, right? So I've got a memory address like 0x1 and 0x2 and 0x3, etc., right? It's just going to go on like that, okay? What we did in our last example was we created an integer, and we stored the value 10. So let's say, and we called it example, right? So let's say maybe right here at this memory address, okay, at 0x1. This is where our int example was, and inside of it, we stored the value of 10, okay? So what now happens is anytime that we use this example variable, it's going to know to go to this spot in memory and pull out the 10 that's being held there, okay? So what we're interested in whenever we use this int example is that value that's stored here, okay? But then maybe somewhere down here, okay, let's call this, 3, 4, 5, let's call this 0x6, okay? Down here maybe we created something called a pointer, right? So a pointer still takes up space in memory, okay? But what that pointer stores isn't going to be a value like 10, it's going to be an address. All right, so here I created, remember we created an integer pointer, so an int star, okay, that's for pointer, and we created this and we called it, I think, example pointer. I might abbreviate here, so I'm going to call it example PTR, like this, okay? So we created a pointer right here, okay, for example, and the thing that we stored inside of this was not the value 10, but we set this to be equal to the address of example, okay? So what that's going to do is it's going to say, all right, where did I store that thing called example? Well, I stored it right here at this memory address at 0x1. So 0x1 is actually going to be the thing, the value that I store at this memory address, okay? So 0x1 is the value of my pointer. 10 is the value of my integer, okay? It's all right if this isn't super clear right off the bat. I just kind of want to give you maybe a little bit of a visual representation of how that works. This is not the best visual representation. There are others that are certainly better out there. So if that doesn't make 100% sense and you're curious, I encourage you to go explore some other explanations maybe. But I do want to look at one other thing that we can use pointers for. Okay, so if I scroll down here, I'm going to draw us two different sections. And you might have heard of these, you might not. But here, I'm going to create one section. Oh, not like that. This is called our stack section. And this is called our heap section, okay? And these are both going to be spots in memory. So this right up here that we just drew, this thing right here, this is a chunk of memory that we wrote on the stack, or that we used on the stack, okay? And the stack is basically a whole chunk of memory that gets used up when our program is compiled. So when you say G++ and then the name of your program, all of the integers in your program, all the characters in your program, all of the strings in your program get given some space in this stack memory, okay? So if I come down here, and these are not going to be straight lines, but if I come down here, you know, this might be given to one of the ints in your program, and this might be given to one of the strings in your program, and this might be given to a character, and this might be given to a bool, and this might be a float, and maybe this is also a float, and maybe down here you have an int, okay? And maybe these are all just things that you're using in your program, okay? That your program knows the size of when you actually build it, right? We know that an integer takes up a certain chunk of memory. And so the program knows, all right, if I've got to create 10 integers in my program when I compile it, then I better allocate space for 10 integers over here in this place called the stack. Okay? So the stack is where we're going to keep variables that we know about, that we know the size of, that we know about before the program is actually being run. Okay? But sometimes there will be some cases when we might not know the size of something before we run the program. So let's think about that. I'm going to erase these examples. Maybe we have something, well, I'm going to erase all sorts of crazy things over here if I'm not careful. Maybe what you guys want to do, and I've seen lots of programs that you all have written in which you will probably want to do something like this. Maybe you want to create an array, right? And so some of you, maybe you've created an array that can hold 20 integers, for example. So you're going to allocate this chunk right here. Again, I'm just kind of spitballing here. But let's say that this huge chunk right here is going to be your array of integers, okay? And you know that there are 20 integers inside of here. And we know that because you have in your code, if I pull this up, you've said something like int array of size 20, okay? So this is how I would create an array that's got 20 integers, space for 20 integers inside of it, okay? So when we compile our program, we know, hey, I need space for 20 integers, right? I need that room for 20 integers. But what if you wanted to do something such as letting the user tell us how big that array was going to be when they ran the program, okay? And I know some of you might have done this without using pointers, because I'm about to show you how we do this with pointers. But technically under the hood, you're actually doing what we're about to do. And so sometimes what's going to happen is we're not going to know how big this needs to be when our program is compiled. When we type G++, and we have an array that's waiting to get its size from the user, maybe the user is going to put in 20, and maybe the user is going to put in 200. We don't know. We're not sure. So if that's the case, we're not actually going to make that array, this array that's going to have some sort of length that we don't know about, we're not going to make that over here on the stack anymore. So I'm going to delete this. What we'll actually do is if we want to make an array that's size is given to us when the program runs. So what we say is its size is given to us at run time, not at compile time. Then what we're going to do is instead we will create a pointer, and again, a pointer is going to take up a little bit of memory over here on our stack, okay? So I'm going to create an integer pointer, okay? And what that integer pointer is going to store, remember, just an address, okay? It's going to store an address for us. But all right, what address is this going to store? Well, what we're going to do is we're now going to move over here to this box underneath this section called the heap. And the heap is memory that we as programmers get to use and kind of mess with while our program is running, okay? So what that means is I've got this space over here that I can use while our program runs, which means I don't have to know how big that array is going to be when I actually compile my program. I can tell it while my program is running, hey, I want to use this much of you, or I want to use this much of you, or I want to use a lot. You know, you as the programmer get to tell us how much you want to use. So what we're actually going to do then is we're going to create this integer pointer over here, and we are going to set it equal to some address that's over here on the heap, all right, in this spot in memory. Sorry, that's the ugliest arrow I think I've ever drawn. Let's try that again. We're going to use this integer pointer to keep track of an address that is over here on the heap, in this spot in memory that we get to mess with whenever we want. And this will keep track of an address of an array, all right? So maybe I want my array to be able to store 100 things, okay? So this will be an int array, and it will have space for 100 things, and that was something that the user put in while our program is running. So this integer pointer is going to keep track of the very first address in that array, because remember, an array just looks like this. Maybe I have a 2, a 4, a 6, an 8, a 10, and a 12. But remember, this is address 0x1, this is address 0x2. Arrays are all kept right next to each other. Hopefully that's reviewed to you, right? Hopefully we remember that arrays are all contiguous places in memory, okay? So what this integer pointer is going to do is it's going to keep track of the first spot in memory that our array is using, okay? It's going to keep track of that first spot. So if this was our int array and it went on for 100 spaces and it's living here on the heap, then our int pointer is going to keep track of this very first address, okay? So again, I know that's a lot of information kind of quickly. I don't want to totally replace your lectures for 162, but I'm hoping that you know, at least if it doesn't make sense on the first pass through, you might be able to go back and rewatch this a time or two, and feel free to ask questions if you guys want. But that's what a pointer will allow us to do. It's going to allow us to store the address of memory either here on the stack like we did in our first example, or we can create some memory and store the address of that memory over here in the heap. And that heap memory is really useful when we don't know how much we need when our program compiles. We might want to know how, well, we're going to need to know how large it is when our program runs, like if the user decides how large something is, or if we're reading information in from a file and the file tells us how much information is coming in. Those are examples of times when that information isn't going to be known, when the size of our array, for example, won't be known when we compile our program. There are lots of other reasons we might want to use pointers and use the heap, but that's one of them, and we'll focus on that here for the next couple examples. So in the next video, we'll actually take a look at how to do this thing that we've just done here on the whiteboard. We'll take a look at how to do that in our actual code. So I'll see you guys in the next video. See ya!